Hi everyone, welcome back. Hope you are doing good. This is Mahesh. In this video we will learn about merge sort. So what is this merge sort? So before understanding merge sort, first we need to understand the merging technique. So this merging technique is the heart of our merge sort. So it's very important to understand how merging happens. So basically, let us consider two arrays which are already in their sorted order, and then we want to merge both the sorted arrays. So let us take the example. Let us take a equal to maybe 1, 3, 5, 7 and 9. Let us also take another array which is B, which is 2, 4, 6, 8 and 10. So if you see both the arrays, they are already in their proper sorted order. Now what we want to do, we want to merge these two sorted arrays and get the merged sorted array. So for that, what we can do basically, so what I can do, I can take first this one and then second 2 from this array, then 3 from this array, then 4 from this array, 5, 6 and so on. So what I am trying to do, I am trying to compare elements in both the arrays and I am trying to pick the smaller element first. I am trying to pick the smaller element first. So for that, what I will do, I will place a pointer on both the arrays at the start of the element. Let us call it as I and let us call it as J. Okay, so I want to take another array which is C. Then this stores my combined merged sorted array basically. So now what I will do, I will check these two. So out of these two, which one is smaller? So one is smaller. So I'll pick one. Then what I will do, I will increment this pointer here. Okay, because I cannot leave this pointer here only. If I leave, the next comparison again I will compare with the same number. So I need to increase this particular pointer. Now I will compare these two elements. Okay, which one is smaller? This is smaller. So I'll take that element and again I will increase my j pointer. I'll keep doing this. Now out of these two, this is smaller. I'll pick this and I'll increment this pointer. Okay, so next 4. So I'll increase this pointer, j gets incremented. Now out of these two, 5 is smaller. So I'll take 5 and I'll increment I pointer. Next out of 7 and 6, 6 is smaller. So I'll take 6 and I'll increment my j. Out of 7 and 8, 7 is smaller. So I'll take 7, I'll increment my I. So out of 9 and 8, 8 is smaller. So I'll take 8 and I'll increment my j pointer. So out of 9 and 10, 9 is smaller. 9 is smaller, so I'll take 9 and I'll increment. So I points outside. When any one of the pointer points outside of that particular array, then I'll stop and I'll simply copy the remaining elements. So remaining element is this one, which is 10. Assume there are more elements here. Say for example 12 and 14. So in that case, I mean this is the best case, because when I gets exhausted, we will stop here and we simply copy the remaining element. So I will increment j. So I'll take 12. I'll again increment j and I'll copy 14. So this is my merged array. So this is how the merging procedure works. So for this one, we should keep in mind the prerequisite is both the arrays should be already in their sorted order. So that is the prerequisite. Otherwise, we don't get the proper sorted merged array. So that's why the prerequisite is both the arrays should be sorted arrays. Okay, so this is the dry run. Let us try to look into the pseudocode. So let us take merge, and it takes array A and B. For now, let us consider these two as separate array, but for our merge sort, it is little different. We will give the same array. In that only we need to tweak a little bit, but for now we will consider this, and we will make the modification when we look into merge sort. So now I have A and B, which are arrays, and they are sorted. That's the precondition. Now what I will do, I will take another variable which is C. So before that, let M be the length of array A, so A dot length, and N be length of array B. Okay, now the resultant array, which is C, it is of length M plus N. So we will take another array C, which is of length M plus N, and this holds the merged array. Okay, now what we will do, let us take two pointers, I equal to 0 and j is also equal to 0. Now while, so what we need to do, we need to iterate until either I gets exhausted or j gets exhausted. So while I less than or equal to, I will say less than m, and j is less than n, what we will do, we will compare both the element at I and j. If a of I is less than b of j, then I should take a of I, because this is a smaller element. So maybe I will take one more, k equal to 0. So what I will do, c of k is equivalent to a of I. Then increment, we will see that later, because there is another condition which is else part. Else I should take c of k as b of j. So c of k is equal to b of j. So once this is done, I need to increment my k. I need to increment, once this is done, I need to increment I here, because I am assigning a of I to c of k. Now if that is not the case, in the else part I need to increment my j. So this is the end of comparison and the merging of the element. Now if there are any remaining elements, then the remaining elements can be either in A or in B. So we don't know, where exactly we get the extra elements. So for that, what we need to do, we can simply use for loop, and I stops somewhere. So I basically stops somewhere. So from there till it is less than its particular length, we will have to iterate. So I less than m, I plus plus, what we will do, we will say c of k equal to a of I. then increment k plus plus. This is for copying the remaining elements in the first array. Then use another loop, and that is basically our j pointer. It has stopped somewhere, we need to continue till the end. So from there, j less than n j plus plus, we will do c of k equal to a of j and increment our j pointer. So what these two loops will do, they will check if at all anything is left from either array A or array B, then they will copy those elements into the third array. Okay, so once everything is done, what we can do, we can simply return our C, which is merged array. So now this is our pseudocode for merge procedure. What is the time complexity? So for this merge procedure, since m is the length of array A and n is the length of array B, so since, what exactly we are doing, we are comparing and then we are copying it to our third array. So basically it is of order m plus n. Okay, this is the time complexity. What about the space complexity? Space complexity is also of order m plus n, because we are using this particular array which is of length m plus n to place the merged elements into this particular array. That's why it is of order m plus n. So this is basically the merge procedure. We will look into its program. Let's create a merge sort.java class. Then let us use public static void main method, and after this let us call maybe public static method which returns us array of integers, and it is called merge, and it accepts two arrays, basically A and B. Now let us create two variables, int m and n, which holds the length of array A and B, and n is equal to b dot length. Then what else do we need? We need int I, which is equal to 0, int j, which is equal to 0, and int k, which is equal to 0. And after this, let's create another integer c, which is of length m plus n. So it will be int. Now once this is done, we will use a while loop, and we will check until I is less than m and j is less than n. What we will do, we will compare a of I with a of j. If a of I is less than a of j, then what we will do, we will copy c of, we will copy the element at ith index, which is a of I, to c of k. Then we will increment I pointer. If that is not the case, then we will have to copy b of j to c of k. Then we will increment j pointer. So once everything is done, we will simply increment k pointer, and this is the end of the while loop. Now once this is done, so we will have to check if there are any elements either in A or in B. This should be B here. Then if at all any remaining elements, then what we need to do, we need to simply copy them to C, array C. So for that, what I will use a for loop, and there is no initializer because we already have I and j. So let's check if I is less than m I plus plus. So this will make sure it will copy the remaining elements to array C. So this is a of I, and I will increment a plus plus. The same thing I will do for the remaining elements in the other array, which is B. So I will take j here less than n, j plus plus, c of k equal to b of j. Then I'll increment my k plus plus. So once everything is done, what I will do, I will simply return my array C. So now the error is also gone, so this is fine. So now what we will do, let us take two arrays, A equal to 1 3 5 7 9 and B equal to 2 4 6 8 10 12 and 14. Now what I will do, I will take another variable C and I will call my merge method and I'll pass my A and B to it. So once this is done, now I want to check what is there in C, which is a merged array. So let us try to print that int num from C, then system dot print, instead of ln I will simply print the number, and once after that I will copy this line and I just place a space after each num. So I will save this and I will run this method. So if you see, we have the merged array which is in the proper sorted order: 1 2 3 4 5 6 7 8 9 10 12 14. So basically 10 12 14 are the remaining elements from the second array, because it gets exhausted when it moves out of the array A from the first point. Now let us look into this merge procedure. If at all we have only single array, but the thing is half of the array is sorted and the next half of the array is sorted. But if you look into the full array, that is not really sorted. Let us look into an example here. Maybe this is one array. So let us say I have 2 4 6 and 1, maybe 3 and 5. So if you see this array, so this is sorted till here, okay, and this is the remaining part is sorted. Now what I want to do, I want to take these two arrays as two arrays and I want to merge them. So if I want to merge them, what I will have to do, I will have to keep a pointer here and I will have to keep a pointer here. Okay, then I need to repeat the same merge procedure. So I will compare these two. This is smaller, I'll take and I'll increment this. I'll compare these two. This is smaller, I'll take 2, I'll increment this. I'll compare these two. This is smaller, I'll take and I'll increment. And this, out of these two, this is smaller, I'll take this, I'll increment. This is smaller, so I'll increment, I'll stop here, and this is the remaining element, so I'll take and I will place it. So this way we get the sorted merged array. But I want to do this step here in the same pseudocode. So here we used two separate arrays, but now that is not the case. I have only one array, which is A. So if that is the case, then what I should pass along with this, what is the lowest element, what is the mid element, and what is the highest element. Okay, so three things I should know, because my first pointer points to here, which is the low, and my second pointer which points here, which is one place after my mid, and this is my mid. My mid is nothing but the length of first array, and this is my high. Okay, so with this what I will get to know, low to mid is my first array, and mid plus 1 to high is my second array. So what I will pass low, mid, and high. So these three parameters I will pass here in the same pseudocode. Then what I will do, so maybe my M will be mid. Okay, and my N will be, mostly we will take it as high only. Why high? Because its first value starts from mid plus 1, so its highest length is high. So I will change these two, and this C will be the length of array. So basically length of A. Now my I points to low, and J points to mid plus 1, and my K points to my low, because it is starting from here. So I will have to copy the element at the same position into the new array. So my K will be low. So this is the change, and then this will continue as it is. And what I need to change after this, so K will be pointing to this. Yeah, this is sufficient, I think. So with this, I mean, we can merge two sorted arrays, the part of array basically. I mean, they are part of the same array, but part of it is sorted, mostly half of it is sorted, and another half of it is sorted. But if you combine everything, it is not sorted. So we will use this particular logic to sort. So at the end, we get this particular array which is merged and which is properly sorted. Now what we want to do, we want to replace our original array with these elements. So what I will do, instead of returning C, what I will do, maybe I will write it here. So I will start from for I equal to 0 to n, I equal to 0 to n. I have to move these elements into my array. So A of I equal to C of I. So if I do this, what it will do, it will replace my elements into my original array. So finally what I can do, I can simply return A, or even if we really don't need to return A. Since our original array A is only getting updated, so we can simply access this A after the sorting is done in our calling method. So that's not really required, but or we can simply remove this, and we can end this particular pseudocode. So we will look this pseudocode in action in the real program now. So now let us modify this merge method, because it takes two arrays, but we want to take one array, and also we want to specify the left portion and the right portion of the array. And we will make modification by taking int low value, int mid, int high. So these are the values we take. Then what we will do, we will remove these two lines that is not really required now. So now our I becomes our low, and our j starts from our mid plus 1, and c is our new array, and it is mostly of the length which is equivalent to the length of the original array. So I will pass my high value here, and now my I is less than or equal to mid, and my j is less than or equal to high. So what we will do, we will check if a of I is less than a of j, then we will simply copy a of I to c of k and increment I. And then again, if that is not the case, then we will have to take the element from the right side. So that is a of j. Now here we will make this modification to mid plus, this will be I is less than or equal to mid, then j is less than or equal to I. Then instead of b, we have to take a. So this is done. So this modification is done. But instead of returning C, what I want to do, I want to replace my elements in the same array A. So now what I have done, I have copied the elements to the third array, which is C. Now from C, I want to copy it back to my array A. So for that, what I will do, I will take a for loop, int I equal to 0, I less than C dot length, and I plus plus I is already used, so let us take maybe L. So L plus plus, and then now I want to copy it back to my array A. My array A starts from low, right? So for that, what we need to do, we need to make small modification here. I cannot simply take A of L here, because L starts from 0, but my low, it may start from 0 or it may start from some other index. So what I will do, I will start from low plus L. That way it will start at a correct location in array A. Then I will copy element from C. So this way, I mean, it will replace all the values in array A. Now, with this, anyhow, it is not going to return anything back to us. So I will make this modification, return type as void. Then here I have this particular two arrays. Now I will make it as single array. So if you see, from 1 to 9 it is sorted, from 2 to 10 it is sorted. So what I will make the modification, so I will only pass array A, and my low will be 0, my mid will be 4, and my high will be 9. So now I don't need to assign this back to C here. So I will use the same array A, and I will try to print the numbers. So this way it will merge the numbers from the same array, considering half of the array is sorted and the next half of the array is also sorted. But if you see the entire array, it is not sorted. So let's try to run this. If you see, there is some exception, index 9 out of bound. Let's see if we see the issue. The array is getting the out of bound exception, because here we are initializing C with only high value. So it will be I will be 9, but our size of the array required is 10. So for that, we need a small modification. So for that, what we need to do, we need to say high minus low, then we need to add 1 to it. So this way, it will give us the correct size for the C array. So now if I save and if I run this, let us see, we get the proper merged array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can use this merge procedure for the merge sort, so which we will see in the next video. So thanks for watching this video.